In today's basic organic chemistry class, we are looking at carbonyl compounds, which are aldehydes and ketones. These carbonyl compounds can be distinguished in that in aldehyde, the carbonyl is terminal, connecting with hydrogen, while in ketone, the carbonyl is internal, connecting with alkyl. The simplest aldehydes are called by their common names, such as formaldehyde, acetaldehyde, benzaldehyde, and such likes. Naming them systematically, IUPAC system is employed. In this IUPAC system, the E from alkane is replaced with Al, making it alkanal. From example, you can see the common name is acetaldehyde, and IUPAC name when carbon is 3 is propanal. The same naming of hydrocarbons, but in that case, because of the functional group, priority will be given to the functional group. In aldehyde, a carbon that bears a carbonyl is carbon number 1, while ketone, because the carbonyl is internal, it will be given priority in naming. So when naming, we'll consider the carbonyl and give it the least number on the carbon chain. In industry, aldehydes and ketones can be synthesized using synthesis gas, which is carbon monoxide and hydrogen, with high temperature using coke as catalyst. Air oxidation can also be used in preparation of aldehyde and ketones in the industry. In the industry, catalytic addition of water to ethyne can yield ethanol. Besides, the hydrogenation of 2-methylpropan-2-ol using copper as a catalyst can also be used in synthesis of propanone in the industry. In laboratory, most preparation of aldehyde and ketone are done using oxidation of alcohols. With primary alcohols, aldehyde will be synthesized, while with secondary alcohol, ketone will be produced. A typical example of oxidation reaction is where acidified chromate and permanganate is being employed. For primary alcohol, aldehyde is formed. For secondary alcohol, ketone is formed. But in primary alcohol, when this aldehyde is synthesized and is not removed immediately, the reaction continues and forms carboxylic acid. So that is why oxidation of primary alcohol is termed to form carboxylic acid, because the aldehyde produced, if not removed, will continue with oxidation until all the hydrogen is removed and carboxylic acid is formed. So if you are in CBT exam and you see oxidation of primary alcohol with acidified chromate or permanganate and there is option of carboxylic acid, it is more appropriate. Except the question is, which of the following can be used in synthesis of aldehyde? Oxidation of primary alcohol is correct. But when limited oxidation is the target, when you don't want any further oxidation of this aldehyde to carboxylic acid, PCC, which is pyridinium chlorochromate, is employed, because other reagents are going to cause this primary alcohols to produce carboxylic acid. During oxidation of secondary alcohol using inexpensive reagents, ketone can also be synthesized, such as sodium chromate in acetic acid and PCC. So PCC can also be used in secondary alcohol to synthesize ketones. Dry distillation of metal salt of carboxylic acid can also be employed in synthesis of aldehyde and ketone. When calcium salt of carboxylic acid is added with calcium formate, aldehyde will be formed. But when 2 moles of calcium salt of carboxylic acid is used, ketone is formed under dry distillation. In reduction of acid chloride, aldehyde are being formed. But in this case, a special reducing agent is employed. This reducing agent is lithium aluminum hydrogen tritertiary butoxide under acid hydrolysis. So whenever you see any question on reduction of acid chloride, remember it's going to form aldehyde and not ordinary reducing agent, but there must be tertiary butoxide in the reducing agent whenever you're talking about reduction of acid chloride. The properties of aldehyde and ketone. The carbonyl group in aldehyde and ketone makes them moderately polar, but they cannot form hydrogen bonding with themselves, but they can form hydrogen bonding with water. Aldehyde and ketone have lower boiling point when you compare them with alcohol of comparable molecular weight. Because of their polarity, it contributes to their reactivity. Reactions: nucleophilic addition reaction, condensation reaction with derivative of ammonia, haloform reactions, reduction, and oxidation will be considered. Chemical properties generally, mostly is addition reaction. In this addition reaction, there's always formation of hydroxyl. Remember, because the carbonyl is going to break the bond connecting carbon and oxygen, which is a weak pi bond, is going to break towards oxygen. So that is what we're going to be seeing happening in some of the reactions we're going to look into. First is addition of hydrogen cyanide. From this equation, you can imagine that sodium cyanide and dilute sulfuric acid is being employed as a reagent, meaning that these two reagents are going to combine to give rise to hydrogen cyanide. So when it happens, then there will be a cleavage, as we're going to see in the next slide, to oxygen. So oxygen become carbanion, while carbon become carbocation. Then the cyanide, which is carbanion, is going to connect to carbocation, which is carbon, while hydrogen, which is carbocation, is going to connect to oxygen. That's how cyanohydrin is being formed. And under hydrolysis, that cyanide is going to form carboxylic acid. So hydrolysis of cyanide in every reaction gives you carboxylic acid. Looking at the mechanism of cyanohydrin, the sodium cyanide and dilute sulfuric acid give yield to hydrogen cyanide, and which is going to form our cyanohydrin. In the same manner, addition reaction with Grignard reagent is going to form alcohols. Remember, this topic has been treated under our method of preparation of alcohols, under alcohols. So when you use methanol, you're going to get primary alcohol, but any other aldehyde apart from methanol is going to give you secondary alcohols, while ketones is going to lead to tertiary alcohol. So that's the reactions of carbonyl with Grignard reagent. Remember, we are discussing about reactions of carbonyl compounds. Next reaction is condensation reaction with derivative of ammonia. All the carbonyl, both aldehyde and ketone, can react with derivative of ammonia, and they will eliminate water. That is called condensation reaction. In this reaction, what happens is that the oxygen from carbonyl is going to take 1 mole of hydrogen from derivative of ammonia, and it will be eliminated as water. So the two compounds will then come together, meaning that where oxygen left, the nitrogen from the derivative of ammonia is going to come and form bonding, and we're going to get a compound which is a giant molecule with respect to the starting materials. When I'm using hydroxylamine as my derivative of ammonia in reacting with carbonyl compound, I'm going to form oxime. When using hydroxine, I'm going to form hydroxone. Phenylhydroxine, product will be phenylhydroxone. The same thing that happened is what's happening. Water is being eliminated and the other reagent condensed together to form a giant product. 2,4-dinitrophenylhydroxine is the Brady reagent that is used to validate the presence of carbonyl compound. So the 2,4-dinitrophenylhydroxine is that orange or yellow PPT or crystal that is formed when this Brady reagent is added into carbonyl compound. With semicarbazide, semicarbazone is also synthesized. This is a nucleophilic addition reaction. Halogenation of carbonyl functional group can also be achieved using phosphorus pentachloride. This does not give rise to hydrogen chloride as a byproduct, like as we can see in alcohols, in the sense that in this reaction of carbonyl and phosphorus pentachloride, Gem dichloride alkane is a product. The next reactions we are going to talk about is aldol condensation reaction. Aldol reaction is a reaction that gave rise to hydroxyl aldehyde or hydroxyl ketone in the presence of an alkali. So two aldehyde or two ketone that have alpha hydrogen, at least one alpha hydrogen must be present for the reaction of aldol to take place. So in that case, two aldehyde in the presence of an alkali is going to yield hydroxyaldehyde. If I'm using ethanol, I'm going to get 3-hydroxyl butanol because there are two of them are coming together. How would this be? Let's look at the mechanism. The base is going to abstract the alpha hydrogen. Now, what is the alpha hydrogen? When a compound has functional group, the carbon next to the functional group is called the alpha carbon. In this case, the functional group is carbonyl. So the first carbon is the alpha carbon. So the hydrogen of this carbon is the alpha hydrogen. And these hydrogen are all acidic. So a base will come and take it to form a carbanion. This carbanion is going to come and attack the carbon. Remember, a carbonyl compound is very electropositive because oxygen is highly electronegative. So the bonding will break towards oxygen, making the carbon of carbonyl highly electropositive. So that is where the carbanion is going to come and bond to extend the chain, forming this intermediate. So under acid hydrolysis, a hydroxyl butanol will be formed. So that is the mechanism of aldol reaction. Using 2 mole of propanone. Remember, the simplest of ketone is propanone. In that case, propanone has 2 alpha hydrogen because all the methyl are connected to carbonyl, making it each of them can be the one used to produce a carbanion. Then the carbanion is going to come and attack the carbonyl carbon, because the carbonyl carbon is highly electropositive and electron deficient. So hence we're going to form a product. So whenever I'm using propanone, the compound I will get cannot be anything more than 4-methyl 4-hydroxyl pentanone, in the sense that the carbonyl functional group is internal. This methyl becomes a substituent, while in aldehyde there's no terminal methyl, it is hydrogen. That's why there was no substituent in ethanol. When these aldol products are being obtained, their dehydration using sodium hydrogen sulfate is going to help us to form unsaturated carbonyl compound. It can be unsaturated aldehyde or unsaturated ketone because of removal of water. Next is cross aldol, which is called Claisen condensation. Cross condensation reaction takes place between aldehyde without alpha hydrogen. So it means that one must have alpha hydrogen and one will have alpha hydrogen. Example is benzaldehyde and acetone. Benzaldehyde does not have alpha hydrogen and acetone has alpha hydrogen. So in a reaction, they ask you a question, they give you a reactant, and they say which of this will undergo what. And whenever you're seeing two carbonyl compounds with alpha hydrogen that are undergoing aldol. But when you're seeing compounds, one have alpha, one does not have, it is cross aldol. Canizaro reaction, we are dealing with aldehyde that cannot undergo aldol. It means there's no presence of alpha hydrogen. So Canizaro is no alpha hydrogen. Now, and the example is methanol or benzaldehyde. And in this reaction, they are going to undergo self-oxidation and reduction. So when they do self-oxidation, they're going to form carboxylic acid. Self-reduction is going to form alcohol. Now, when you're using 2 mole of benzaldehyde, one of them will form alcohol and one will form an acid. This is the mechanism of Cannizzaro reaction. The first one, remember a base is involved. This base is going to come and attack the carbonyl carbon, which is electropositive. Then when the oxygen when the anion is coming back to form a carbonyl, hydrogen is breaking out to form an acid. This is self-oxidation. In self-reduction, the hydrogen that was released, because it's happening in the same system, is going to come back and form the alcohol in self-reduction. But when we're talking about cross Cannizzaro, it means that I'm not going to use the same. I'm going to use, both of them must not have alpha hydrogen, but it must be aliphatic and aromatic. In that case, my aliphatic is going to form the carboxylic, while my aromatic is going to form the alcohol. Slide is telling us that when I am doing my cross Cannizzaro, my aliphatic can never be the alcohol. Aromatic must be the alcohol, while the aliphatic must be the carboxylic. Why distinguish between aldehydes and ketones? First, oxidation reactions. Aldehydes are easily oxidized, while ketones are not. Ordinary mild oxidizing agent can oxidize aldehyde, while ketone cannot be oxidized. Aldehydes are easily oxidized to carboxylic acid. In oxidation of aldehyde, we can use acidified permanganate or chromate to give carboxylic acid. Aromatic aldehydes are not easily oxidized like aliphatic. So whenever we are talking about oxidation of aromatic, we are using alkaline permanganate. But when we are talking about aliphatic, we can use acidified permanganate. This aromatic aldehyde, which is benzaldehyde, can also undergo auto-oxidation under UV light to form carboxylic acid. In oxidation of ketone, because ketone is difficult to oxidize, so heat is added to the acidified permanganate or chromate. In that case, there will be cleavage of bond, and a mixture of acid, each containing a fewer carbon atoms than the starting ketone, will be formed. The next is silver mirror, which is Tollens test or Tollens reagent test. In this reaction, the aldehyde is going to reduce the silver mirror reagent to silver, and this silver is going to be seen at the neck of the test tube. That's why they call it silver mirror test. In that case, the aldehyde itself will be oxidized to carboxylic acid. Aldehyde is going to reduce Fehling solution, which is blue, to reddish brown precipitate or brown precipitate of copper 2 oxide. Itself is going to be oxidized to carboxylic acid. Carbonyl can also be reduced to alcohol. It can be reduced to primary or secondary. It means that my aldehyde will be reduced to primary alcohol, my ketone will be reduced to secondary alcohol. Reduction of carbonyl compound to alcohol can be done in 2 ways. First, they can be reduced to primary and secondary alcohol respectively. Secondly, they can also be reduced to hydrocarbon. A reduction to primary and secondary alcohols, the reagent will determine the products. Now, if the reactant is unsaturated carbonyl compound and the product formed is saturated alcohol, then the reagent employed will be reagent used in hydrogenation. In that case, hydrogen in nickel or hydrogen in palladium or hydrogen in platinum will be used. But if the product formed is unsaturated alcohol, So we go for mild reducing agents such as lithium aluminum hydride or sodium borohydride, because this mild reducing agent is going to protect the double bond. In reduction of carbonyl compound to hydrocarbon, Clemmensen reduction reagent is employed, which is amalgamated zinc in conc HCl. This is going to turn the carbonyl into hydrocarbon. So my benzaldehyde will be turned to toluene using amalgamated zinc on conc HCl. Reaction is haloform reaction. This reaction was discussed under alcohol. This is a reaction that is only feasible for carbonyl compounds that have methyl connected to carbonyl. So in alcohol, ethanol or propan-2-ol is positive for haloform reaction. In carbonyl compounds, aldehyde and ketone that have methyl connected to carbonyl, which can be ethanol or propan-2-ol or any other. The only aldehyde that can be positive to haloform is ethanol. Others are ketones, because remember, ketone is connected to 2-methyl. So ketone is more reactive than aldehyde. Remember, the compound to be feasible with haloform or iodoform reaction, the carbonyl must be connected with methyl. So that is what you look for when the question comes, which of the following can undergo haloform or iodoform reaction. Look for a carbonyl compound or alcohol that have methyl connected to the functional group. Remember, ethanol under oxidation is going to form ethanol. That is why ethanol and ethanol can undergo haloform. Others are secondary alcohols. And the byproduct of this iodoform is a yellow crystal of triiodomethane, which is very important. We've come to the end of this class. And the things you don't understand, drop the question in the comment section. And don't forget that your success is in your hand. Put in more effort. If you're such a person that can listen to something once and you're good, listen to it and answer the question that is going to come further. And if you're such that have to go through it several times, go through it several times. I wish you success in 2 and 3 exams. Thank you.